Hello, and welcome back to Patch Math, where today we are going to continue talking about why coterminal angles are important in pre-cal. Now, we've found some coterminal angles, and in the last one, we found a coterminal angle that was on the unit circle. And I told you that there is a reason why we need to find these in order to use this unit circle. So if we want to find the tangent of 5 pi over 3, we have our calculator, but if you're going to be in any of the classes that I am helping with, you're not going to have your calculator when you're asked to do this. Instead, you'll be asked to probably memorize the unit circle. I highly recommend understanding it and recreating it as opposed to memorizing. But there are a few key things that for the purposes of this video, I do need you to memorize. We are dealing with Pythagorean identities here. All right. So sine and cosine are explicitly given on our unit circle. I don't know if you remember SO, CA, TOA. That's an acronym, SO, CA, TOA. If we look at a little side problem here with SO, CA, TOA, let's just use pi over 6 for example. We are actually dealing with triangles on the unit circle, whether you're aware of it or not. That hypotenuse, that radius is always 1, super important. And we know that because of this ordered pair right there. It tells us that this radius is equal to 1. That length never changes. And I need you to know in the middle of a lesson, I forgot that fact because I hadn't looked at the unit circle in a really long time and missed that until I looked at that ordered pair. And I was like, wait, the radius doesn't change in length. So what we're looking at here is a right triangle that goes up to there and then comes on down. I made that a little bit too big. And if we look here, that's a right angle. We're measuring this angle right here. 30 degrees, pi over 6, whatever you want to say. So we teach you the opposite. All right, so the opposite, that's our height here. Notice height is y. What's our y value? Well, our y value is 1/2. All right, so that height of that triangle right there is 1/2. Well, that same ordered pair tells us the base of that triangle. If we are trying to find, well, we know the hypotenuse is 1 that's important. So we can go ahead and fill in so here in a minute. Well, let's just say we need to go ahead and figure out what that base is based off of this. If for some reason we need no adjacent, like per cop. All right. We know this bottom here, well, that's our x value. That's the length from 0 on the x-axis. And so you can see that that length is pi. What I'm saying, square roots of 3 over 2. There is not a pi in that. My bad. And again, it's kind of blurring all together, but I am representing that right there. And that is that square roots of 3 over 2. So what we find when we envision these triangles is that sine ends up being y and cosine ends up being x. And you're about to see how those kind of interact with each other. All right, this is y, this is x. And you'll see why is y and x. One, we have the hypotenuse. So it means the sine. It's an acronym to help us remember the sine, in this case, of pi over 6. It's going to be equal to, well, opposite, 1/2 over hypotenuse, 1/2 over 1. Anything over 1 is itself. So the sine of pi over 6 is 1/2. Well, look at that. That was our y value. That is y. The y values on the unit circle are sine, or an example y. All right. Now let's go ahead and apply ca. Ca is cosine. All right. Cosine of pi over 6. We can apply that ca. Now that's adjacent over hypotenuse. That's adjacent over hypotenuse. Adjacent is the side length that touches our angle. In this case, square roots of 3 over 2. Our hypotenuse is still 1. Super important. Our hypotenuse is still 1, and so that is square roots of 3 over 2. Now, I'm getting ready to show you why TOA, or tangent, is opposite over adjacent. And you're about to learn that we don't visually see tangent on the unit circle like we do sine and cosine. But tangent is a ratio of sine and cosine. In this case, we're going to go ahead and use TOA, the opposite over adjacent. We find that the tangent of that angle, tangent of pi over 6, is equal to that opposite? Well, opposite is 1/2 over adjacent. Our adjacent is square roots of 3 over 2. If you look at this, that 1/2, what was that in our ordered pair? It was our y. All right, the opposite is our y. The adjacent is our x. Tangent is a ratio of y to x, and this is an example, all right? An example of y works out that way. Now, we can, anytime we want to find tangent, y over x, sine over cosine. So that is important to note. We can write this in many different ways. All right, I want you to see this in all the ways that you could possibly see it. Tangent of pi over 6 is equal to sine of pi over 6 over cosine of pi over 6. So what we're doing is just kind of exploring why these things exist this way, how they work together, and we're going to apply it in a problem here in a minute. All right, again, y is the axis, and we just simplify these fractions up here. And I'm going to go ahead and bring this on down while I do my work over here. So in this case, we're going to apply keep, change, flip. You'll notice I put a fraction over a fraction. I put each one in parentheses for a reason. It's hard to see sometimes when we have a fraction over a fraction that we can kind of apply keep, change, flip. That's something that most students learned a really long time ago. So in pre-cal, it doesn't seem to like come up naturally. And so we have, and also you're used to seeing those written out horizontally, not vertically like that. So 1/2 over square root 3 over 2 turns into 1/2 times 2 over square root 3, and this works out really nicely. Two's cancel. We're left with 1 over square roots of 3. Now, if you're in any math class, you know we do not like that radical in our denominator. We can rationalize it. That's not the point of this video, so I'm not going to go too far into it. Anytime you need to rationalize, you're going to use that identity property again. That's how you deal with fractions. Make them look different, essentially. In this case, we want to get a radical to cancel out. We just multiply by that very same radical. What we do to the bottom, we must do the very same thing to the top so that this equals 1, and that's an identity property. We're not changing its value, just the way it looks. So the tangent of pi over 6 ends up being square roots of 3 over 3, because square roots of 3 times square roots of 3 is square roots of 9, which is just 3. So that was like a little side lesson of how the unit circle works with triangles, what you learned in geometry about SOHCAHTOA, and how, if you want to find tangent of anything, well, simply take your sine over your cosine, or even more simply, your y's over your x's on your unit circle. Now that we've had that little side lesson, we're going to apply it really, really quickly to this problem. Now recognize that I am asking you to find the tangent of 5 pi over 3 here. That is the same thing. I want to mention why we use coterminal angles is because if I asked you, and I should have wrote this one instead, to find the tangent of 11 pi over 3, you would say, based off from coterminal angles, and you would show the minusing the 2 pi, all right, that a coterminal angle is 5 pi over 3. All right. Now, in that case, we're going to come over here to 5 pi over 3 on the unit circle. I'm going to go ahead and take my old highlighting off. 5 pi over 3 is 300 degrees on the unit circle, and we are going counterclockwise. And this is where we start. That little Pac-Man looking symbol is our angle. With that being said, we can find tangent as y over x is our y at that angle is negative square root of 3 over 2. So this is equal to negative square roots of 3 over 2. And that green is hard to see. I'm noticing that. And we are going to divide that by Y's over x's, 1 over 2, 1 over 2. And we end up with keep change flip, negative square roots of 3 over 2. Division becomes multiplication, and this becomes 2 over 1. We only have multiplication and division happening now. In PEMDAS, those are treated as equally. We can choose to do that division first, leaving us with negative square roots of 3. And so the tangent of 5 pi over 3, or the tangent 11 of pi over 3, or any coterminal angles to those angles, is negative square roots of 3. All right, and there you have it. Your math knowledge has just been excuse me, your math knowledge has just been patched over coterminal angles and how we can apply them with the unit circle to find trig, or to solve trig equations. Thank you very much for your time.